What should have happened in the 5G airport spat?
Welcome to the Techno King.
The introduction of new 5G technology near airports have thrown airlines and mobile phone carriers into a frenzy, resulting in an epic clash. It is feared by the airlines that emissions from 5G towers at a specific radio frequency would interfere with the radar altimeters that planes use to determine how high they are above the ground when visibility is limited. To recognize how critical an instrument like the altimeter is, the Federal Aviation Administration (FAA) has enacted rules that prevent low visibility instrument landings at specified airports if the 5G is turned on, and that force pilots to abandon landings if the weather changes. Despite the fact that this topic has been well documented for quite some time, radio signal disputes in the United States are handled by the Federal Communications Commission (FCC), which is entrusted with settling the situation. It attempted a number of procedures to avoid many problems, but none of them was sufficient to appease the aviation community, which threatened to cancel flights. As a result, the deployment was pushed back, but it appears to be back on track now that the dust has cleared, hopefully. It's the same thing as having Wi-Fi routers that won't work if there are other Wi-Fi networks nearby, as if you were living in a remote area with no other Wi-Fi networks. The landlord granted the go-ahead for the tenants to use the malfunctioning appliances. Everything was well until someone moved in the next door and set up a Wi-Fi network that was completely usual and in compliance with the rules. When an emergency monitor is required to summon an ambulance, the likelihood of yours failing is quite low. It's important to you that your neighbor's Wi-Fi is turned off in order to prevent it from interfering with your own failing network, and you should have foreseen it a long time before it happened. Since the beginning of radio, we've used spectrum partitioning to address radio conflicts. Broadcast radio and television are separated into channels or stations to get exclusive use of a specific station of the radio spectrum, and so are applications and groups of consumers. The frequency of the old-fashioned carrier waves determines the allocation of spectrum. A filter is used by FM radios when they're tuned at 101.5 MHz, so that they only pick up radio transmissions that fall inside that range. You and everyone else's filters will prevent interference from that broadcast at 101.7 MHz from interfering with the station that you're listening to at 101.5 MHz. That's because radios have good filters and sending power is managed. In the music industry, we refer to a band as a collection of frequencies, and the size of the band is the bandwidth. The analog approach of sharing the ether was used by every old-school radio and TV station. There were improved methods for sharing radio spectrum later in the 20th century, such as digital methods. A vast frequency band can be shared by all users, but digital technology can segregate the signals in a variety of ways. Instead of allocating specific frequency signals and ranges to individual users, we created solutions. We call it multiplexing, and the new ways are substantially superior to the previous method of allocating permanent channels. Large number of cell phones can communicate simultaneously with the same cell tower in the same region because of this technology. You can also use this method if you have more than 50 PCs in a room. If there was 40 megabits of bandwidth available, all 50 machines sharing would add up to less than 40 megabits in the earlier versions because they were compelled to take a fraction of that resource each. There are newer techniques that get around this and allow for a significantly larger total bandwidth. It's incredible, and it only gets better from here. In the end, it turns out that sharing is caring, and we know how to do it today, in that they propagate differently. Antennas and coils are set to specific frequencies, but they no longer play a significant role. Radar is an ancient form of radio that is still used by aeroplanes today. You can't just fire a burst and listen for the return like in 1940s radar. An advanced radar system sends out a wave with an ever-changing frequency and monitors the frequency it receives back. It's better, but you still need effective filters to avoid interference from other transmitters operating at the same band as you. International authorities have designated the spectrum between 4.2 GHz and 4.4 GHz for use by airplanes and radar. Because planes cross international boundaries on a daily basis, this needs to be an international effort. A 4 GHz signal has a frequency 40 times greater than that of the previously mentioned FM radio stations. For this reasons, your AM 1 MHz operates in a tunnel, but your Wi-Fi 2.4 GHz can't travel to the next room because high-frequency radio waves behave differently from low-frequency radio waves. Radars benefit from 4 GHz's ability to operate in a straight line. Governments around the world, including those in the United States, have designated the frequency slightly below 4 GHz for use in 5G mobile phones. Everyone but satellites and few remaining fixed wavelength links are allowed to utilize the guard band from 3.8 GHz to 4 GHz to protect the plane. This was solely for the purpose of safeguarding the aircraft's radio communications. Because they're in such high-risk roles, they get a ton of extra protection. The 280 MHz band between 3.7 GHz and 3.98 GHz was recently auctioned off for $81 billion by cell phone companies, and the 220 MHz band above that is being left empty to protect aircraft radios from having noisy neighbors, even though it is presumably worth around another $60 billion, and the total of the guard band and aviation band, which can be used for satellite, may be valued at $120 billion just in the United States. In some planes, the aviation radars are of inadequate quality. Their filters aren't up to snuff. At the time of their construction, they had no neighbors but satellites that didn't interfere. Because of this, they made them shoddily. Because of this, some fear that even the buffer zone in place, a 5G tower near an airport approaching utilizing the spectrum the FCC auctioned to sell firms, could still interfere with them. Some of the history and studies on interference can be reviewed by former FCC chairman Tom Wheeler. In the unlikely event that a faulty radar is used in conjunction with an automated aircraft in a landing zone configured incorrectly, there may be a danger to the passengers. Fortunately, the radars on most large jets have greater filtering, so they are not at risk. This is entirely the fault of aircraft radars in terms of radio resource allocation. Despite many warnings, they refuse to pay the money necessary to upgrade their radio equipment in order to avoid radio interference. The FAA also bears some responsibility. They issued specifications which were last updated in 1983, informing the corporations that it was fine to use subpar radars. Those specifications should never have been developed in the first place, and the order to upgrade them should have been issued long ago. These planes are still flying, and a 5G tower might cause one of its altimeters to malfunction. That's a topic of discussion. The aviation industry has published a study that demonstrates how it can be done. It is claimed that these studies are defective and illustrate only extreme scenarios, which the mobile phone industry claims is highly unlikely to occur. Although some countries have stricter laws on broader guard bands, 5G has been turned on without incident in many countries. Because of this, airlines claim that the United States is a larger danger. We fully expect the airlines to exercise extreme prudence in this situation. We trust them with our life. That's what makes them worry about the possibility, even if it's far-fetched. There's a good reason why they didn't just go ahead and spend their money on interference-free radars that worked properly. For them, it's been a rough 2 years, and this deadline may have given them the extra push that they need. Thanks for watching this video. Make sure to hit like and subscribe to this channel for more.